Imagine, for a moment, the vast, silent emptiness beyond the orbit of Neptune. It is a realm of unimaginable cold and perpetual twilight, where the sun is just another bright star in the cosmic tapestry. For centuries, we thought we had mapped our solar system's major residents, from Mercury all the way out to the distant dwarf planets. Then, in 2016, a whisper of an idea turned into a shout. Astronomers announced they had found evidence not of a small rock, but of a giant unseen world lurking in the shadows. A ninth planet. The excitement was electric. It felt like the golden age of exploration all over again. But this time our ships were telescopes, and our ocean was the cosmos itself. What would this world be like, this phantom giant? We can only speculate, painting a picture with the laws of physics and a touch of imagination. Planet 9, if it exists, would be a true behemoth, perhaps 10 times the mass of our own Earth. It would be an ice giant, a cousin to Neptune and Uranus, but far more isolated and mysterious. Its surface, if you could call it that, would be a turbulent atmosphere of hydrogen, helium, and methane, swirling under pressures we can barely comprehend. It would be a world that has never known the gentle warmth of a nearby star, a lonely wanderer on a vast, looping journey that might take 10,000 years to complete. This planet would be a king in a kingdom of darkness. Its sky would be an unchanging panorama of stars, more brilliant than any you could see from Earth, untainted by atmospheric haze or city lights. Comets, its nearest neighbors, would drift by like silent ships in the night. The sun, our glorious, life-giving star, would appear no bigger or brighter than Venus does in our own twilight sky. It would offer little warmth, leaving Planet 9 in a deep freeze, with temperatures hundreds of degrees below zero. This is a world defined not by what it has, but by what it lacks: light, warmth, and companionship. It is the ultimate cosmic hermit. The very idea of such a world captivated us all. It was a reminder that our own solar system still holds profound mysteries, waiting to be solved. The search for Planet 9 was more than just an astronomical exercise. It was a quest to complete the map of our own cosmic home. Finding it would not just add another member to our planetary family. It would reshape our understanding of how solar systems form and evolve. It was a tantalizing prospect, a ghost story told with data and equations, and astronomers across the globe were desperate to be the first to unmask the ghost and prove it was real. So why did scientists believe so strongly in a planet they couldn't see? The answer lies in the subtle language of gravity. Everything in the universe pulls on everything else. A constant and invisible cosmic dance. Out in the Kuiper Belt, a vast donut-shaped ring of icy bodies beyond Neptune, astronomers noticed something strange. A handful of the most distant objects were not moving as they should. Their orbits were bizarrely aligned, all swinging out in the same direction and tilted in the same way, as if they were being shepherded by an unseen hand. This was not a random pattern, it was a clue. Imagine you are watching a collection of marbles scattered on a smooth, flat table. If you roll them randomly, you would expect them to end up all over the place, pointing in every direction. But what if you noticed that 6 of these marbles, all on one side of the table, had rolled into a neat cluster, all pointing towards the same corner? You would immediately suspect something was pulling them. You might guess there is a hidden magnet under the table, its invisible force field corralling the marbles into an unlikely arrangement. The clustered orbits of these Kuiper Belt objects were just like those marbles. This gravitational magnet, astronomers calculated, had to be enormous. To have enough pull to influence these distant objects across billions of kilometers of empty space, it needed to be a planet. Not a small dwarf planet like Pluto, but a substantial world with a powerful gravitational field. The calculations painted a consistent picture. A planet with about 10 times the mass of Earth, orbiting the Sun on a long elliptical path, was the most likely culprit. This unseen giant was the perfect explanation for the strange behavior of its tiny, icy neighbors. It was a beautiful and elegant solution to a perplexing cosmic puzzle. This is how science works. We observe the universe, we see something that doesn't quite fit our expectations, and we formulate a hypothesis, an educated guess, to explain it. The Planet 9 hypothesis was compelling because it explained several anomalies at once, not just the clustered orbits. It was a powerful theory that made a specific, testable prediction. If you point your telescopes in the right direction, you will find a planet. The hunt was on. It was a cosmic game of hide-and-seek, with gravity providing all the clues we needed to start the search for this hidden giant. For years, the evidence for Planet 9 seemed to be mounting. Astronomers dedicated countless hours of telescope time, scanning the predicted regions of the sky, hoping for a faint pinprick of light moving ever so slowly against the fixed background of stars. The mathematical models were refined, narrowing down the search area and giving everyone hope that a discovery was imminent. The story of the missing planet captured the public imagination, a grand cosmic mystery unfolding in real time. We were all on the edge of our seats, waiting for the curtain to be pulled back and for Planet 9 to take its bow on the celestial stage. But science is a self-correcting process. It demands rigor, and it doesn't care about our hopes or our stories. As bigger and more powerful sky surveys came online, they began to map the outer solar system with unprecedented detail. These new projects, like the Dark Energy Survey, were not specifically looking for Planet 9, but they were cataloging hundreds of new trans-Neptunian objects. This gave scientists a much larger and more unbiased sample to work with. And when they looked at this new, more complete data set, the original tantalizing pattern began to look a lot less clear. The signal started to fade. The problem was that the original discovery of those clustered objects might have been a trick of observation. Early surveys were often pointed at specific parts of the sky at specific times. This can create something called observational bias. Think back to our marbles. What if you only ever looked at one corner of the table? You would only ever find the marbles that happen to roll into that corner, and you might mistakenly think that all marbles are drawn there. Some scientists now argue that the original clustering was a statistical fluke, an illusion created by looking at a small, biased sample of distant objects. As more and more objects were found by the new, wider surveys, their orbits did not show the same strong clustering. The neat alignment that pointed so convincingly towards Planet 9 began to disappear, washed out by a sea of new data points that were pointing in all sorts of different directions. The strange movements that had launched the entire search seemed to be vanishing, like a footprint being slowly eroded by the wind. The gravitational pull of the hidden magnet was no longer as obvious. The case for Planet 9, once so compelling, was now looking much weaker. So, what does this mean for our ghost planet? Is the mystery solved? Is it time to close the case on Planet 9? Not so fast. While the original evidence has been challenged, it has not been completely dismissed. Some astronomers still argue that when you look at only the most stable, most distant objects, those least likely to be disturbed by Neptune, a hint of clustering remains. The signal may be weaker than we first thought, but it might still be there, buried in the statistical noise. The debate is far from over, and it highlights the difficult, painstaking nature of scientific discovery at the frontiers of knowledge. The search itself has not stopped. In fact, it is about to enter a new and exciting phase. The Vera C. Rubin Observatory, set to begin its grand survey of the sky, will be a game-changer. Over the next decade, it will catalog an enormous number of new objects in the outer solar system, creating a map so complete that it should settle the debate once and for all. If there is a massive planet out there, its gravitational signature should be impossible to miss in the Rubin data. If the clustering truly is a statistical ghost, this new survey will definitively lay it to rest. Even if Planet 9 turns out not to exist, the search will have been incredibly valuable. It has spurred a new wave of exploration into the dark frontiers of our solar system, revealing a wealth of information about the Kuiper Belt and its strange inhabitants. Science is not just about finding the right answers. It is also about asking good questions. The question of Planet 9 has pushed our technology, our theories, and our understanding of the cosmos. It has reminded us that even our own backyard is vast, complex, and full of surprises waiting to be uncovered. The quest continues. Planet 9 might still be out there, a shy giant hiding in the dark, its orbit more unusual than we ever imagined. Or the strange patterns that captivated us might be a ghost in the data, a phantom born from incomplete knowledge. Either way, we will keep looking, we will keep observing, because that is what we do. We are explorers on an unending journey of discovery, and the universe is not required to conform to our expectations. The mystery endures, and the cosmos awaits.